Hello, everybody. I gotta say, I'm really impressed to see this many people in this room because they're setting up the bar outside. So, thank you all for being here. And it would be rude for you to leave right now. It's not open. It's not open, but yet, by the way. So hi, I'm Mark Kuemerle. I work for Marvell. Today, I'll be the MC for the Bunch of Wires Implementers panel, and we're all, I think, very happy to be here. I just want to go through our panelists, let them introduce themselves real quickly, and then I'm going to share just a few high-level slides, just because every good meeting needs some slides. And then we're just going to get into questions. This is participation, highly encouraged discussion. I'm going to have a few questions to start out with, but if you guys are so excited to ask questions, you want to interrupt me and throw yours in there, then we're definitely game for that. I want to start by handing it off to Sid to just give us a brief introduction.
Thank you guys, and thanks everyone for being here. So I'm Sid Sheth, I'm founder CEO at D-Matrix. We are an AI computing company, and when I say that, we are essentially building a compute platform for AI inference, the inference workload, and how to deploy it at scale. So when we, I just want to talk a little bit about our association with the BoW and ODSA activity. When we started the company 3 years ago, we essentially made a decision to chipletize our computing platform. This was back in 2019, and that's what brought us to BoW. And as we go through the panel, I'd like to talk a little bit about the implementation work that we are doing there, and it's been a great journey for us so far. But I'll hand it over to Anu.
Hi, everyone. I'm Ramamurthy from Microchip. I've been in the world of semiconductors for 20 plus years. And for the last few years, been looking at the world of chiplets and see how it roadmaps into Microchip's vast product catalog and how to make use of that technology to further our products. Also, I am a great supporter, passionate about women in STEM. I've been a mentor for a couple of years, so shout out to Tech Woman, which is a state-run program. Go Amber!
Yay.
Great. So my name is Alon. I'm the co-founder and CEO of a company called Blue Cheetah. I also happen to be, now the technical co-lead of the ODSA Bunch of Wires working group. I didn't start out there. I joined, I'd say, I don't know if it's halfway, but let's call it halfway through about the effort. So Blue Cheetah provides customized die-to-die interface solutions. There's a longer history that I'm happy to tell anybody about, but that's kind of our primary thing these days. And one of our early customers, sort of kind of turned us on to BoW and the work that was going on there. And we obviously got involved to try and make sure that we thought it was moving in the direction that we thought would be best, not only for ourselves but for the industry as a whole. And so that's why I'm here now.
Great. Thank you, Elad. Now I'm going to go through the obligatory slides, but I'm going to be really quick because I know we're short on time. So I want to start out with, why are we all here? Why does everybody care about die-to-die interfaces and chiplets? I think the last 3 speeches really covered a lot of the reasons, but I just want to touch on it to remind everybody that we're really here because there's a lot of challenges in front of us. And I think the way that we see it in OCP ODSA is that every challenge brings a new opportunity to innovate. So I want to talk about the biggest challenge that at least I've experienced over the last few nodes. I think, Bill, your discussion on Moore's Law is alive and well. My experience is that it's not, except for in one aspect of building cutting-edge semiconductors. What we're seeing from an area scaling going from node to node is plotted here on in the white line, but what we're seeing from a cost scaling and investment scaling going from node to node, Moore's Law is alive and well. So we're not getting the benefit that we saw from Moore's Law from an area point of view, but it costs just as much to make those advancements. So what are we doing about it? What are people doing about it? They're making less chips. Big investment to go in and build a chip, so you make less chips. Well, you have less chips that you can invest in, so you got to make that one chip do more things. You make that one chip do more things, you add more features, and it makes it just like this truck here on the right-hand side. There's too much stuff on a given chip to basically be able to practically build it. So we're stuck in a conundrum. The solution to the conundrum is modularity. That's why we're all here. We need to break things into pieces for it to make sense. People are doing it with things like SerDes chiplets, like breaking memory and bringing memory onto a package, scaling chiplets, scaling systems into multiple chiplets by breaking them into pieces, adding I/O chiplets, 3D stacking. We've got to find ways to basically be able to build that super solution and scale up and down. So I think we're all here because we believe that standards are existential. We really need to have standards for die-to-die communication that are open and interoperable and collaborative. So we're really, as a group, I think, trying to be a really big part of that in creating these open standards that the industry can use. With that, I think everybody already introduced themselves, but here's how you spell their names if you'd like to send them an email after the discussion. I see people taking pictures. That's great. We could put their home phone numbers here if you'd like. First of all, I have some questions for the panelists, but is anybody brave enough to start out with a question from the audience in the beginning? Or you guys want me to get us warmed up? Okay, I'll get us warmed up. This is a softball question, guys. We recently released the BoW specification version 1. I want to know, maybe Elad, because you put more time and effort into this version than anybody else ever has put into a bunch of wire specification. But how do you feel about it? Was there enough detail to actually build and implement a PHY? Was there anything that you feel like it's really missing that we should have done or that we need to do very quickly to patch it up?
Great, thanks, Mark. So I'll attempt to answer with my Blue Cheetah hat instead of as you said, the person that did a lot of the writing. And many people came before me. In general, I think we did a very good job on sort of the electrical features and specifications. I think all of that is in a pretty good shape. There's obviously learnings that we're all going to have. I think there are some things on sort of the fringes of what may or may not be in a spec that if we want to just make sure that everyone really gets it right, we probably want to explicitly write in. A lot of what we're doing in the revision 1.1 is specifically just trying to catch these kinds of things. So for example, in advanced packages, you very clearly want redundancy from a overall yield perspective. And it wasn't that I think that anyone sort of had a whole lot of doubt about how to do it. Mm-hmm. It's just, go write it down explicitly, make sure people, sort of are doing it the same way. Things like, additional test patterns, specific, steps one would take to get these things in. These are the types of things that we're adding in right now. Beyond, just really additional feature sets, like as I mentioned, more energy proportionality, power management, things of this nature. But generally speaking, I think sort of as a core PHY electrical standard, and again, I'm somewhat biased, but this was something we definitely focused on a lot, and I think we did a pretty good job there.
Yeah, absolutely, and I want to thank you personally for a lot of heavy lifting going into that specification. Thank you, Elad. Anu, what do you think?
So I don't have the same experience that Elad had because he's put in a lot of work into it, he and Bapi and Mark. But from a user point of view, I think it's an overall a good spec. It provides the outline for a standard that can be used across industry. So people look at it, there's a good spec, you can build something based off of it to standardize a die-to-die interface. And then IP providers, providers of ESD clamps, providers of standard cells can also align that IP to fit into that spec. Mm-hmm. So it provides an start for an ecosystem. And for someone like Microchip, we look at that spec and we go, we've got this ton of these products and a lot of them in mature process nodes. How do we put these pieces together? Because everybody addresses the leading edge process node. Everybody's talking 5, 4, 3, 2, 1. Wait, what about 65? There's a lot of stuff done in 65 which actually makes a lot of money. Mm-hmm. So how do we use that? And I think the spec gives you a broad outline on how to use it.
Great. Thank you, Anna. What about you, Sid? What do you think?
So, we are users of the IP or the spec itself, right? We are using the interconnect to really connect the chiplets in our computing platform. And when we looked around in 2019, I don't think we really even saw anything out there that was so well organized and a community effort truly around a die-to-die interconnect. And BoW was certainly one of those. And that is why we joined and started contributing to it. The good thing that our experience over the last 2 years has been is the fact that as we've been building, and we're building this IP inside the company, so we have been contributors and users at the same time. And the good thing that we saw from our perspective was the fact that as we were building the silicon, right, we could learn things about what's happening and feed it back into the spec, right? And those learnings went into the spec based on real silicon being built, right? And just because I'm talking so much about the silicon, I should mention that the silicon will be back next, actually in a couple of weeks.
Hey,
so that should, yeah, so I think it's a proud moment for the whole community. I'm assuming this might be amongst the first BoW silicon, that the industry will see. So it's definitely a great moment. And a lot of the feedback, that we have provided has been based on the learnings of building that silicon. I think the one area, you talk about omissions, I think that we probably struggled with a little bit was probably around the link layer. I think the physical layer spec is absolutely solid. It's robust. I think, I can speak from experience. But when it comes to the link layer, I think we had to actually go off and create a solution of our own because there was just not enough detail in the link layer spec. And I think that is being worked on right now. But that would be one area that I would probably call out as an omission.
Great. Thank you, Sid. Any questions from the audience? Okay. Then I get to go on to question number 2. So the bunch of wire spec, I think, was intentionally built to allow a fair amount of freedom from an implementation point of view. For example, bump pitch can be varied, bump pattern can be varied, and it's interesting that freedom allows the designer a lot of choices in how they implement it. But my one question to you, and maybe we'll start with Sid again, and we'll just go backward. Like, do you feel like there's too much freedom in this spec? Do you wish that some of the things were a little more hard-coded in the spec to I guess maybe limit choices but enhance interoperability?
Yeah, I mean, we always like freedom, obviously, when you're one of the folks building it. But I think there's a bit of a yin and yang there, right? I think you don't want too much freedom, but you don't want to constrain it to the point where there is no creativity, given where we are in the development cycle of BoW. From our opinion, the one thing that really is important is really defining a very good channel spec, right? I think channel specs are super important. I think as long as you get that right, and I think a lot of work went into the definition of the channel spec for BoW. So I think that was the right thing to do. But then giving some freedom around the bump pitch or the bump map and not really constraining that, given that there are people trying to do this across different process nodes and with all the supply chain constraints that are playing out in the industry, you're dealing with a whole new set of OSATs out there who are building these substrates. It was a good thing not to constrain the bump map and the bump pitch. I think there was some amount of freedom. That was actually a good thing. I think as we go further and silicon comes back and we learn more and it becomes more mature, I think probably you can constrain it a bit more. But I think given where we are in the cycle, I think it's been a good decision to offer that freedom.
Great. Thanks, Ed.
Yeah, so freedom is good in limited quantities. I think, sounds like a democracy, doesn't it? So I think the issue we would have as users of chiplets coming from, which integrate the BoW-PHY and come from different vendors and trying to put them together is, there's an outline. It tells you what the insertion loss should be, and then you decide how to design the receiver and transmitter to fit into it. But one vendor could put in a superset of the spec. The other might not. So testability could become an issue. There's a lot of good stuff with the freedom, but I think those are the pieces that need to be ironed out. So I think possibly enforcing certain tests, like certain PRBS patterns, forcing loop-back testing, and so you know that it's both sides are going to have it, and you can design your DFT to take care of it. I think those would be useful. Okay,
so your recommendation is that Elad should strong-arm the committee into...
He just changes... he changes everything to must.
As
opposed to
a lot of
should.
A lot of new musts on testability.
That's easy.
That's it. That's
Very
it.
easy, yes.
Find and replace, should, could to must. Yeah. How about you, Elad? What do you think?
Yeah, no, so from our perspective, as Blue Cheetah specifically, one of the things that, actually drew us to, besides obviously having a customer that, was involved in this, that drew us really to be very heavily involved here was that we saw sort of, even in the earlier phases, this was really sort of the outline of something that could be flexible and could be customized. And in our view, from our experiences so far, and Anu and I think Sid both touched on this, there's so much variety of what people are trying to do in these products that may end up as being chiplets that, it's going to be very hard initially to say, oh, you must do X, Y, Z, particularly on the packaging and other sides, right? I think, testability, everything, no disagreement. But I definitely think, bump maps and, sort of data rates and, sort of some of these other things, if we had sort of tried to lock them down too specifically, I think we would have just excluded sort of entire swaths of the market.
Yeah,
And that just, I think at this stage probably would have been a strategic mistake, at least just given our goals for the spec.
Yeah, absolutely. Thanks, Elad. And I really love how you've brought multiple personalities into the panel discussion.
I can argue with myself, in other words.
The Blue Cheetah Elad, the OCP Elad. It's great to have both of you here joining us today. If there's any questions from, perfect. There's a question from the room.
So we would all love to have a chiplet marketplace in the future, right? Where we can all just leverage each other's great chips, right? And bump map is an important piece of it. But what do you guys see as we move forward? Since, how do we get to certain XY and other things that you could actually reuse in different designs, whether it's IO chiplets or other things? Do you guys have a vision for how we get there over time?
Yeah, go for it, Elad. We'll just go back and forth, I think.
Yeah, no, so I think the approach that we attempted to take was, sort of start out with what we believed were the minimum set of things that you need to define to sort of get at the interoperability. So for example, I think it's actually wire order and sort of layering that matters in terms of the interoperability and not necessarily the bump map itself of the PHY. And the overall, let's say, approach that we're thinking of is, can you take things, put in the recommendations, put in sort of, okay, here's what we think the defaults would probably look like, and then let the market drive that forward into, well, what actually turns out to be the ones that, people really will, sort of standardize on. And I think all that will happen and will evolve over time. But I think, I believe you touched on this as well, I think what's going to happen much sooner than that is there's going to be sub-ecosystems of groups that will sort of coordinate and say, okay, here's the subset of things we're going after. Here's the things that we're going to sort of agree on that make sense in our context. And there may indeed actually be multiple of those sub-ecosystems because there's enough differences in kind of those requirements that, as far as I can tell, it would probably be a cost adder and a noticeable one to sort of force everything onto all of them. And at the end of the day, if that means that, okay, there's like 3 subvariants or 2 subvariants or however many it turns out to be, I think that's actually still a very large success because at the end of the day, sort of particularly for hardware bent folks, there's like every last cent of cost that we're looking at in every single one of these products, and these decisions can cost you those few cents, and and cause the business people to say, oh no, I can't do chiplets because it's actually more expensive.
Yeah.
So that's kind of the vision that we've been pursuing.
Great. What do you think, Anna?
I think what Elad mentioned was really important, the signal ordering, which determines how your routing should look. That's, I think, a really great starting point, because in order to fix these bump pitches and patterns, you're basically eliminating choices for people. You're saying, well, you're going to have to go with a 130 micron pitch, even though your technology allows you to do 100 micron, because that's the only one allowed. Now, that's a big difference for a company. Similarly, on the advanced packaging, you could say the micro bump pitch could be anywhere from 25 to 55, but how do you hard code that? So I think starting out with a signal ordering system, saying if you do this, your routing is going to be relatively efficient, is a good point, but maybe eventually it'll shake out to 2 flavors of each. I honestly don't know, but time will tell.
Yeah, absolutely.
And I think, just maybe as a side note, that particular innovation came, probably right in the beginning. I don't know, Bapi, if you have more history on it, but it was there, certainly in 2019 when I started.
Yeah, it was very early. Yeah, very early. Yep.
We are undertaking an interoperability exercise as part of the BoW, and Elad has a chiplet on one side and we have a chiplet on the other side, and I believe our bump maps may not be the same, right?
Our bump maps are very different. Yes.
Very different. So I think that's a great start. We're going to find out, right? But
I'm the interface.
but I think it's path-breaking work because look, I mean, there are a lot of PHY specs out there, right? I mean, and how many of these have actually tried to chipletize? What are the decisions one has to make to chipletize these physical layer specs, right? And in some ways, BoW is amongst the first to kind of take on that work.
Yep.
There is going to be some learnings here as we go through this exercise. But I bet you in like a couple of years, once we reflect all those learnings in the spec, then we can go towards the vision that you just highlighted, right? Is really kind of, having third-party chiplets come in. And anyone who follows the basic set of principles in the BoW spec will be able to fit into the ecosystem.
Yeah, and I'm totally going to steal your picture, by the way, with all the different chips and standard form factors. Because that really gets you thinking about, okay, we can come up with interfaces, we can demonstrate that they can plug and play together. How do we move to that? How do we move to that next step? And can I define a geometry and solve that Tetris problem in a way that kind of future-proofs me for any kind of chiplet integration? And that's going to be, I totally agree, that's going to be our big challenge. Yes, another question?
So I may ask you again to wear your UCIe hat. You have that one too. In UCIe,
I think you're stealing my last question, but please go ahead because it's better from the audience.
UCIe defines, and I think rightfully so, bump maps for both standard and advanced packaging. And I think that in order for the industry to coalesce around best practices, and so to speak, you mentioned the package being the new motherboard. Then if you look at the motherboard, the connectors are standard, and the bump map, I think, is the connector. So I think standard bump maps and all of that is essential. Now, of course, the work of this group has preceded the UCIe spec, but I definitely think that moving forward, specifically this thing should be standardized.
Yeah, no, so completely understood, and I guess I'm going to try and phrase this in the appropriate way.
Which hat?
Yeah, all of them. Yeah, all three hats.
Triple personality.
Yeah, exactly.
Oh, great.
I think actually Amber did a great job pointing out exactly some of these issues here, in that this isn't a question of just the interface, right? Like, make the interface a literal magical wire that jumps from chip A to chip B, and there's all kinds of other issues that would have to be standardized before you can, sort of actually get to what you're shooting for, right? And so I raise this not as sort of saying, oh yeah, it's just not going to happen. It's just that I think there's a much bigger challenge ahead, separately from the interface alone, right? To actually get chiplets from totally independent vendors, from totally independent sort of developments, timelines, and everything to actually interoperate with each other. Not the least of which is exactly one you just mentioned, which is, well, okay, fine. Like, even if I have the I/O as a standard bump map, what about everything else, right? What about all the other bumps, right? And I think it's gonna take a while. I mean, and I don't say this in a negative way. I think this is a challenge we as an industry need to address to really get to that end vision of, okay, like, how do we come up with these things where vendor A, vendor B, vendor C are all going to agree, and it's going to work for a pretty broad variety of the applications that they're shooting for, and not get to that couple extra cents of, oh no, this is like too much cost, right? That's I think the challenge for us.
So I was going to say, at EPEPS last week, for the first time, there was this engineer from NVIDIA, Nitya Shankar, and she actually had a data where her claim was, if you fix the bump map and if you fix everything else, you're making the package more difficult to manufacture. You fundamentally need some freedom in order to make a more manufacturable, more reliable package, was the basic crux of the point. So in some sense, that freezing
Yeah.
And we shouldn't.
And we're
I
all
think-
going to disavow any knowledge of
No, I mean, and we don't need to speculate, right? Like there's
specification. And
there are trade-offs in interoperability versus all of these other factors, and one can weight one higher than the other, and and we're all sort of placing a little bit of a bet on where we put those weights, right? I think that's.
Yeah, and the cost of silicon is expensive. So, non-optimized bump pitches could cost somebody a lot. So it's non-trivial to just, I think, say, well, pick flavor of the day is A, B, and C. Maybe that's what it'll end up to be, but we need to have a fair amount of thought put into it.
Yeah, no, I would agree because, as we were going through actually building the silicon, right? I mean, we gave that feedback, right? I mean, we were coming in and talking to the group and saying, hey, look, we are running into these challenges. You guys had a set of challenges, and we reflected all that feedback. So there is the real world practicality of building silicon and feeding that into the spec, and that requires a certain amount of freedom, at least at this stage in the game. So I think it is definitely warranted.
Yeah, great. And that actually gets me to my next question, which is very related to that. And I even had to bring out my elephant icon to identify the elephant in the room today. So I wanted to bring up and just address it, right? That there's a ton of momentum. I think we've seen it everywhere around UCIe. And I really want to get opinions from our panelists wearing whatever hat you'd like to wear. Do you folks see UCIe as something that's complementary to a bunch of wires? Do you see it as an opportunity to basically converge to the one parallel interface to rule them all? What kind of, how do you see it in influencing the industry, influencing people's choices, and how do you see the use cases really shaping up? And Anu gets to go first because Elad pointed to her.
So, one ring to rule them all, I don't know if that would happen. I think I see them as complementary. So coming from a microchip point of view, right, what I see is they both have their application spaces. The UCIe is based on PCIe CXL, and it works beautifully within that spec. The protocols line up, and we play in that space.
Yep.
And so, it's a great spec. But like I said, Microchip's got a ton of other products which we want to potentially chipletize and build these solutions. In which case, if we're not looking for, we're looking for something very lightweight, very simple, and something that gives me several degrees of freedom, then I would probably lean towards the BoW. So in my opinion, they both have their space. 5 years from now, maybe I'd be proved completely wrong. But as I see it now where I'm sitting, I think they both have enough room to grow and enough people to use both of them to be successful.
And do you see an opportunity for convergence? Do you see a way to influence each other?
I'm not going to say anything
To
right
find
now.
an end? Okay, fair enough. Okay, one of you guys has to go next.
I think I'm next. Yeah, so and I certainly, I very much agree with what Anu was saying. I think, and this kind of touches on some of the prior questions that were asked here as well, and that I think there were two different, sort of sets of philosophies and, sort of potential trade-offs that were made on, some of these software engineering questions, where BoW, I think at the end of the day, really is very well suited for more die disaggregation applications where, again, you need something that's more lightweight, more streamlined, more, sort of tunable to the individual needs of specific disaggregated chiplets. Whereas UCIe, very much took the very successful approach that PCIe did and is, mapping it into that application space. And, again, there are definitely going to be cases where you say, look, like, I care about interoperability and nothing else, and that makes a lot of sense, right? So I do think that there, is very likely to be parallel sort of things developed there. And honestly, I imagine there'll be chiplets that will have both interfaces on them, again, for the purposes of, hey, here's this thing that was really the disaggregated section of my die, and whether it was, as a single vendor or with a smaller cabal of, vendors we all coordinated on, here's how all this stuff fits together, and here's my ports for interoperability with anything else that may come down the road. That all seems like a very natural engineering solution to me.
And I think you've just created a new paradigm for us, the chiplet cabal. So I want to
Right.
thank you for that, Elad. How about you, Sid? What do you think about these two different standards?
I don't think it's a zero-sum game. I think it's an and, right? And there are many instances outside of, UCIe and BoW. We are now beginning to go inside the package, right? But once you go outside the package, you go outside the system. I mean, there are many instances of multiple protocols, multiple interconnects, even within Ethernet. And I spent 20 years in the Ethernet world. There's so many different flavors of Ethernet. There is short reach Ethernet and medium reach Ethernet and long reach Ethernet, and these don't interoperate, right? So yes, the MAC layer may be the same, but the physical layer, they don't interoperate.
Yep.
And even for interconnect outside the boxes, there is InfiniBand and there's Ethernet, and there are some folks who are HPC players who want to use InfiniBand, and everyone else wants to use Ethernet. And Ethernet is widely popular, of course, but there are multiple standards. So once we pull the interconnect inside the package, why do we think that we need one size fits all, right? There is parallels in a world outside the package, outside the system, where that's not true. So once you come inside the package, there is going to be one protocol that is maybe widely popular, but there's going to be others that coexist that service a certain need, right? And in our case, we were looking for something that is extremely energy efficient, high bandwidth, and cost effective, and BoW met those needs. And it's pretty lightweight. The link layer is pretty lightweight, so it really services the needs for applications like those. In my opinion, it's an and, it's not an or.
Great. Thank you, Sid. Are there any other questions from the audience? Yes. Oh, can you stand at the microphone maybe, so whoever's recording gets it for posterity? Yeah. And we promise not to let Boppy go off on a tangent without putting him in front of a microphone again.
Yeah, so I agree that there's probably going to be a coexistence between UCIe and BoW. What about Open HBI and AIB? Do you think they'll be obviated with these two?
That's a great question that everybody's afraid to answer.
You're giving me a fourth hat here. No, I'm joking.
No. Let's see where this goes.
No. So I think the answer is certainly in the near term, yes, because there are solutions out there based on AIB, industrial, high volume production. I don't know for sure whether or not OpenHBI has industrial insertion points, but certainly it's got sort of strong enough and important enough players that I wouldn't be surprised if it does. I do think that there will be convergence down likely to a couple of them at the end of the day. I guess you can guess as to what my guesses are likely to be, but I do think that there is going to be coexistence, and a lot of these things are all about standing up ecosystems and sort of figuring out the trade-offs, figuring out sort of what really is important, and I do think particularly within the ODSA, which obviously includes both OpenHBI and bunch of wires, this group has had a lot of I'd say very positive sort of community effort. And sort of has learned from each other and has open discussions, and has been sort of very collaborative in the way it operates, and I think that's very, very healthy, and people will learn from each other, and we'll figure out how to make things all work together.
Yeah, that actually brings me to a backup question that I had here, if I can.
Uh-oh.
I may or may not have seeded that backup.
If I can dig deep into the folded up paper in my pocket. I think, Elad, the one thing that you just mentioned kind of brought up something that I was thinking about earlier, and just from participating in the Bunch of Wires committee over, I don't know how many years, Boppy, a lot of years. One thing that I've noticed is that the community behaves in a different way than I've seen in other standards organizations. It seems to be more, let's say, collaborative and more consensus-based than I've seen. We tend to discuss something until we can find something that's reasonably acceptable to everybody, and it doesn't seem like rarely have we gone to a point where we've done decisions based on voting. I can't think of any decision that's really stuck that was based on voting, Boppy. I don't know, what about you? But I think that's a very unique thing, and I just would love to hear your opinions as participants in the organization. Do you guys see that that's potentially limiting in terms of, are we making progress slower than we could have? If we just should put a thing on the agenda, vote for it, go. Or do you see it as beneficial to the kind of the health of the overall spec in the ecosystem? Whichever, yeah.
Let me try. So, a couple of things. I think the collaborative nature of the way the spec was put together, given the point at which we are as a group, as an industry, and with all the things that are happening around us, I think that turned out to be a very good decision, right? Because it allowed for live feedback into the standard, and that was important because there was lots of path-breaking work that was being done by the group. There was many firsts that were being broached by the team, right? So I think having a way of course correcting when you're putting or doing something like that across a wide array of people, you don't want to enforce a voting structure, I feel, on a group like that and say, okay, guys, let's mandate a vote, let's make a decision, let's move on. It may not be the right decision because new data might emerge literally like a few months later and you might have to go revisit that, so what's the point? Now, once we have a spec, now if you want to come and make changes to that spec when people have actually gone off and started building and the ecosystem is beginning to develop, that would be a good time to have a voting structure, right? So you can say, okay, guys, there is implications here, there is consequences here of changes, and we should really all agree as a group, and voting in that case makes sense, but maybe not during the development phase.
Yeah. So vote when it's a critical imperative. Yeah. What do you think, Anna?
I think for something to be successful and truly open source, it's got to be sort of consensus building. And I agree with Sid that the voting comes later, so you get some data back, and then the data proves something you've decided as a consensus to be false or slightly incorrect, and then you go in and rethink. But I do believe that this community, and one thing you brought up is truly very collaborative and very welcoming, for sure, Mr. Bapi, for sure. I think they embrace everyone who comes in. And it's truly open source because it actually values everybody's opinion and then takes a collective decision and listens to the back and forth very patiently. And I think that's truly phenomenal. I don't see that even in single organizations these days. So forget cross organizations.
Now, from Elad, who voting would probably have saved you at least 100 hours of work, what do you think?
No, actually, overall,
God never sleeps.
No, right. No, overall, I actually, if I could go back and do it again, I think I still would stick with the approach that we took. And I think that one comment that I wanted to make is that in some senses, I think the design philosophy of attempting to make the spec itself sort of minimally, sort of requirement and set things out that are sort of, to build an ecosystem, set things out that, sort of are the minimum required to actually get the interoperability, but leave a decent amount of flexibility, in my opinion, sort of helps with having this more collaborative process, right? Because you don't have to get everything, quote unquote, right. You just have to get everyone to sort of agree, okay, yeah, like this is really the principle that we need to follow, and and if I want to do X and they want to do Y, as long as we figured out the principle, great, that works. So I don't think I would change that part. I do agree with Sid that obviously, as people have ecosystems and sort of momentum behind certain things that would have direct time, money, risk, etc. consequences, that's where you probably have to make a more quote unquote democratic process. Whether that's a more correct or incorrect different question, right? But you have to make it more democratic just so that these things can be resolved in a in a way that people will sort of accept, right? But as I said, I think overall, I think that actually did go quite well. And to be frank, I think that's really a credit to the community, to Bapi, to yourself, to others who sort of seeded all this and set the culture and the tone from the beginning the right way.
No, thank you. Are there any other questions from the audience? Don't be shy. Is there some burning question you guys are just dying to know the answer? Yeah, go ahead, Bill. Can you step up to the microphone? Yeah.
I think in this room, probably you have the 99% of the bunch of wire experts. So I think one question that I would have is that how do you multiply this room so that if you can multiply this room, then you will have more applications, users, and not just for the bunch of wires benefit. It is for the benefit of our industry. Sure. And
Great.
so I think it's important for us, I know nothing about bunch of wire, but I put myself us.
That's
I think it's important for us.
Yep, that's a great question, Bill.
To
And
multiply the knowledge.
yep,
And I think there are very few people in the world that, like Elad has done, develop this.
Yeah.
And so if he can stand up and said, let me teach people how to develop a spec, or something like this, I would just say that the way to do this is to multiply yourself. And how do you multiply yourself?
yeah, that's a great question. Thanks, Bill. And for the record, I don't think we're in the high 90s of bunch of wires expertise in the room. I think we were probably less than 5% from the folks in this room. But it's a very good question. And let me be. I'm not going to wrap up because I have one more question for the group. But I just want to. I don't know if moderators are allowed to ask questions, but or allowed to answer them. But I just want to. I want to talk to your point, Bill, that the Bunch of Wires group gets together literally every Wednesday at 9 a.m. Pacific time in a completely open call that literally any human being could join, like school kids could come and be a part of it. They never are. I don't know why.
Maybe the timing is bad.
Right. But right. But as the group tries to be as open and inclusive, we don't have secret meetings. Discussions on details if they're handled in small groups, are usually brought back to the bigger team for discussion. So I'd say, from an organization, we're pretty open to bringing new people in. But let me just run through the panelists. Like, what do you guys think? How do you, as Bill said, how do you kind of spread the word and get people ramped up in knowledge?
We send Elad on a dog and pony show. We send him around.
Yeah, the Elad World Tour.
Yeah. More talks at conferences.
Just to be clear, I'm also less than 5% of the expertise on the committee, so so we should send not just me, but appreciate the sentiment.
5%, what are we then? It's all relatively speaking, right? So I don't know, more conference appearances, webinars, and since it's truly open and promoting the way the ODSA works.
Yeah. What do you think, Sid?
More proof points, maybe.
Good
right?
point.
I think we have 2 proof points coming up, and can we multiply those proof points? More silicon, really create an ecosystem gradually, right? Once you create an ecosystem, then the multiplier effect kicks in right away.
Yeah, exactly. No, I think you teed it up perfectly. I agree. I think the more proof points are out there, the more sort of people see. Here's what you can do. Here's what has been done. I think that will certainly help to amplify. There are a number of other things that I'm sure we could be doing from a marketing perspective, and we should indeed do them. But I think the proof points and just encouraging participation and sort of activity wherever we can is going to be very helpful.
Great, thank you. And I had perfect. Go ahead.
Question. Maybe I'm going to embarrass myself, but I'm going to ask this anyway.
There is no wrong question in this room.
There was, I don't know, I think it was the person from Google who showed us a slide there, a wonderful slide with this vehicle which was pretty much tipping over with all the stuff in it.
That was me.
Sorry, my bad.
We can go back to that slide.
So
it took me a while to get marketing to clear that.
Again, that slide to me just says that there's too much stuff in a chip.
Yeah.
You need chiplets.
Absolutely.
So now we're defining what chiplets are, and we're trying to figure out what kind of standard interfaces are there, what kind of this is there. We're trying to do this. We're going to try to put all of this stuff together. Now we're just saying, aren't we just saying that remove all these things in this particular vehicle that's there, but put it more evenly so that we can stack still more?
Exactly. It's exactly the
Seeing it the right
point.
way, or am I just
No, yeah, that's exactly the point we were trying to make. Is you throw everything all together because you spend so much money to build a chip, right? You invest so much, you're going to throw everything into it, and so the way to make it financially viable is instead of one big giant truck full of everything, build it in smaller trucks with less stuff in each truck and stick them together. Put them in a convoy instead of one big truck. But thank you. I'm glad you love that slide too. I do as well. What do you guys think about it? Do you guys see like that paradigm happening in your applications? Do you see like you got way too much stuff, you got to break it up into pieces?
It happens all the time. You basically build a spaceship of a part,
Yeah.
which is now too power hungry, too big, too expensive, but that's because you can't produce multiple large pieces of silicon with small SKUs. So,
Yeah.
but if you had all of the functional pieces as chiplets, think how quickly you could put them together. Your time to market is faster, and now you're not making this giant omnibus of things. So I think that's a great picture.
Yep.
Yeah, there was an interesting sort of comment that was made to me by one of my customers, pointing out that there's obviously the semiconductor manufacturing reasons why chiplets make sense in terms of die size, yield, so on and so forth. But from a human engineering perspective, the comment they made, and this is an executive who was making this comment. You'll understand why I say that in a moment, saying a great thing about chiplets is that if I've got the I/O hub chiplet and I've got my CPU chiplet, whichever one is behind can't hide behind the other and say, oh no, but actually like they're never going to tape out in time.
CPU to finish their
Exactly. No, what do you mean? Like they're not done. Like so clearly, I'm not the critical path here. Right?
Sounds like an executive.
No,
that's
exactly.
a really interesting perspective.
But it's in my observations, there's actually a lot of truth in this. And it's a function of human management and behavior and everything. But it's very natural, right? You look at the critical path, you say, okay, look, like I'm going to be done here. The critical path must be there. And if you can just actually break these things up, then you can actually no, like that doesn't matter. You need to get out. Because,
You're all stuck on that truck, and one of those sacks is in the critical path, right?
exactly?
Yeah. What do you think, Sid? Do you see this really affecting your applications as well?
Absolutely. There's one side benefit, by the way, of which I don't know how you would reflect it in this picture, but it is not just cost and power that drove people to chiplets, right? It's also because that's a great way to attack multiple markets simultaneously. If you go back and look at, AMD has multiple presentations where they've talked about this. They were trying to make a comeback and they were taking on Intel, and how do you go after multiple markets and they service the client market and the data center market, and how do you build something that will allow you to modularize a solution across all these markets? And that's what we did at D-Matrix. We essentially chipletized the solution that would allow us to go after multiple different markets at the same time. So if there was a way to reflect that, I don't know, it's you break this into multiple trucks, but some of the trucks can go in a different directions, very easily.
That's a great point. Great point, Sid. And I think unless there's other questions another question from the audience, please go ahead.
Yeah, just kind of interest. Right now you have a 1.0. So what is the need plan for the next? Like you're going 1.1.
Oh, we're already working on it.
What's your focus? We can share.
Yeah, that's Elad's next baby.
Don't tell my wife.
Go ahead.
Yeah, no. So there is indeed I'd say there's actually several things in flight that that are worth specifically mentioning. So there's a lot of work actually going on specifically in the link layer side of things. Once again to very specifically try and say, look, if you have some set of on-die sort of networks on chip, how do you disaggregate that in the sort of lowest overhead, lowest latency, et cetera way. A lot of great work that David Kruckmeyer this morning had presented on, and still some more work to be done there. But overall, I think that's a really important direction, and that's a lot of the emphasis now. There's obviously the interoperability effort that Sid and Sid, D-Matrix, and Cheetah, my company, have been working on hard, along with a number of other volunteers from the community, led by JP from Cisco. And I think again that's in the earlier question of, how do you get more people into the party, I think, sort of showing the multi-vendor interoperability, just based on, sort of the meetings that were done in the standards body, I think is a very important step. And then in terms of the PHY specification itself, as I said, there's a number of kind of specific features that from a high level, there's a certain subset of applications that, I think people could figure out how to do, but were not explicitly captured in the 1.0 version of the spec that are now being, written down explicitly. And, there's obviously new challenges, engineering things, but essentially, just broadening out the subset of things that you can actually cover and, what's important from an interoperability, functionality, et cetera standpoint is all being baked in. And as with, the very beginning, as I said, credit goes to folks who came long before me. All this is up on GitHub. You'll see the live edits with, the blue, green, red text of, here's what we know, here's what we don't, here's what we thought about, and that's making really great progress overall.
Great. And I got one more question to kind of wrap us up. And my question's a fun one. If there was one thing you could decide all by yourself, just like even like no hats on, just you the person, not representing a company or OCP, that you would want to change about a bunch of wires, meaning you would do it all by yourself. You don't have to take it to the group on Wednesday. It's just completely all up to you. What would that one thing be? I'm gonna start with Sid on that one because I can see that Elad already has an answer in his mind. What do you think, Sid?
Change the name.
That's a good one.
Yeah, I don't have a suggestion as to what, but I don't know. That just came off the top of my head. So
Change it to something more whiz-bang sounding. Yeah, like a cow. Yeah, a cow. Yeah. Or like super wires 2000 or something like that. Yeah, something futuristic. Nice. I'm gonna point to the guy who came up with that name. What do you think, Anu? What is the one thing, if you had complete freedom to just like take over and do it all your own way, what would you do?
Well, yeah, other than the name, I guess.
You also want to change the name? Wow.
Well, so when I tell people it's called BoW, they go, "What do you mean BoW?" And I go, "Bunch of wires." They go, "Bunch of wires?" and so I feel like we might have to elevate that to gain some respect, maybe, about me. Just saying. But I think one of the things, and I know Elad knows this is one of my pet peeves is for the advanced packaging, I think you need to have repair redundancy as a must. I think there's no choice. We all know there's yield issues with that. And so I know that the spec gives you the ability to do it.
Yeah.
But I think it would be nice to be well defined so that when I buy from vendor A and vendor B, I know both have implemented because the spec says you must and it's not a choice.
Okay. Anu is bringing a must into the committee next Wednesday, everybody.
You can see that's how my house runs. Must.
No, so both the real and the half-joking answer is that, as the technical lead or whatever, I kind of just assume that, if things make sense and, we'll get there, then I'll be able to drive the group and, help convince people. And if I don't, then probably means that I was wrong. So I guess at the moment, nothing specifically comes to mind.
So all of your favorites are already in there.
I wouldn't say all my favorite,
Well, he spent more than 100 hours on it.
Yeah. No, that was just 100 extra hours because we don't vote.
Yeah, no. There are small things here and there for sure, but none of it is maybe to sort of do the former professor thing and change the question. There wasn't anything that, in my opinion, that ended up there sort of because of consensus and not sort of from discussion. And so I think I understand why everything's there the way it is at the moment.
And there was one more question over here. Go for it.
She mentioned it's in the spec, therefore it must be obeyed. Last word. Everyone, there was a common refrain, I won't say the whole thing, but standards are like, nobody wants to look at the other guys.
It's got to work just well enough.
Standards differently.
Yeah.
There's always room for misunderstanding and failure, no matter how tight the spec is written.
Absolutely.
No, I agree, but maybe there's a better chance of success with a must than a should. I don't know.
After first deployment, yes.
That's a great comment.
It's a good point, though.
Yeah, yeah.
211G didn't get fixed until several years of the Wi-Fi consortium being in existence and building interop test labs.
Yep, yep.
And even then, first generation Wi-Fi failed utterly in the field because of user error. Speaking from brutal market experience.
Absolutely. Thank you so much. And thank you so much to our panelists today, Anu, Sid, and Elad. I am really happy that you guys were here. You really made this a joy for me. And I hope that you had a little bit of fun too.
Thank you, Mark, for doing all this.
Oh, thank you. And thank you, audience. And good night.